In the last lecture, I tried to demystify computers a little bit by identifying and examining 4 layers in a computer system: the user, the hardware, the operating system, and the applications. In this lecture, I hope to illustrate and to clarify how these layers interact with each other by examining what happens when you turn a computer on and what happens when you run an application. In this lesson, I'm going to walk you through a couple of illustrations out of this textbook, which some of you may be using in a class that assigns these videos. But don't worry if you aren't using the textbook, just follow along with the video. We'll start with this illustration, which diagrams what happens when we turn on a computer. When we press the power button on a computer, the computer's power supply begins to distribute current to the different parts of the computer so that they can operate. When the CPU receives current from the power supply, the CPU searches for a special program that helps to load the operating system into the computer. For PCs, this program is called the Basic Input-Output System, or BIOS. As you can see in this diagram, it's labeled BIOS. Now, as you may remember from the last lesson, most of the program files on your computer are stored on a hard disk. However, the BIOS is a special program hardwired into the motherboard itself. What does it do? Well, the BIOS grants the CPU access to all of the hardware components that are connected to the motherboard, and it helps the CPU to access the computer's startup code, which is called boot code. Most computers store boot code in the hard disk, but it's also possible to configure a computer to boot from another storage device, such as a CD or a USB flash drive. The boot code is loaded from the computer's storage into its RAM, and the CPU runs the boot code from the RAM. The boot code tells the computer to load the operating system into the computer's memory, and so the computer loads the operating system. Like the boot code, the operating system is normally stored on a computer's hard drive, but it's possible to store an operating system on some other storage device, such as a CD or a USB device. Wherever the operating system is, the computer will load it into RAM so that the CPU can run it. Once the operating system is loaded, it will automatically tell the CPU to run a number of automatic startup applications, such as device drivers, firewalls, antivirus software, the computer's clock and calendar, and other applications that run in the background on the computer. Much like the boot code and the operating system, these automatic startup applications are stored on a storage device, and they must be loaded into RAM before the CPU can run them. Once those automatic startup applications are up and running, the user may begin to interact with the computer via the mouse and keyboard. If you have a username and password set up on your computer, this is the point where you'd be prompted to enter it. So that's what happens when you switch on a computer. Now let's take a look at what happens when you load and run an application. For this, let's look at a different illustration. This illustration shows what happens when you load an application onto your computer. I already said that the operating system will run a number of applications automatically, but many applications are configured to only run when the user commands the operating system to run that application. For example, your computer usually won't run a web browser unless you tell the computer to open the web browser. This curvy red arrow represents a user entering the command to run a program, say by double-clicking on the program with the computer's mouse. This command is processed by the operating system, which is running on the computer's memory. The operating system then accesses the program file from a storage device. Let's imagine that the program that the user wanted to open is a web browser. The web browser file loads into the computer's memory, and the web browser runs from there. The web browser will normally display something for the user to see on the computer monitor, and the user can usually input information and commands into the application through the keyboard and the mouse. For example, users can navigate to web pages by typing a web address into the browser's address bar, and they might interact with web pages by clicking on different parts of the page with the mouse pointer. And here's something more that you should know. As we have seen, applications run through your computer's operating system. That means that anytime you're running an application, it can potentially access anything that the operating system can access. Because the operating system has access to every file and every piece of hardware connected to your computer, every application on your computer may also potentially access any file or any piece of hardware on your computer. So in principle, an active application can access everything in your computer system, even if the user isn't aware of it. This means that it's possible to write applications that use your own computer against you. For example, it would be possible to write an application that records all of the keystrokes that a user punches into their keyboard, and then secretly uses an internet connection to send that keystroke information to some third party. And then that third party could mine your keystrokes for sensitive information, like usernames and passwords or bank account numbers. In fact, many such applications already exist. They are called keylogging programs, and cybercriminals would be delighted to install one on your computer. Okay, that's all for now on these two illustrations. Obviously, there is much more to learn. I just wanted to give you an overview so that you could get an idea of how your computer system is tied together.